morning, good afternoon, good evening, wherever you're based. Welcome to this session on the future of meat and livestock. I think this is a very internationally relevant session, and it fits quite well after the plenary session that was related to food systems and nutrition that just ended. I think we have a great set of excellent speakers and panelists in this session. In fact, it's worthwhile to mention that only two of the panelists are actually agricultural economists. You may guess who they are. Perhaps you find out during the talks. The others are experts from other disciplines, including nutrition, including animal science and climate science. And I think that's an important message. Of course, economists need to work on food systems and food system sustainability, but the broader questions are interdisciplinary, and we need to team up and cooperate with other disciplines. Let me very briefly start by introducing our chairperson. This is Dr. Lindiwe Sibanda. She's professor at the University of Pretoria in South Africa. She's an animal scientist by training, so knows the subject matter of this session very well. But apart from her own research, she's had lots of experience in international policymaking, governance, advisory roles. She has been on the board of trustees for various CGIAR centers. She has recently been appointed to the CGIAR Systems Board. She has been member of the Eat Lancet Commission that many of you know. She's on the Nestle International Board and has also worked for AGRA. So these are just a few of her stations and experiences, and I can imagine no better person to chair this session than you, Lindiwe. Over to you.
Thank you very much, and thank you, Martin, for that warm welcome. Colleagues in the panel, the audience, it's an exciting session. We are here to talk about the future of meat and livestock. There couldn't have been a better subject close to my heart. Martin has already said that I'm an animal scientist. I went out to study animal science because where I grew up in Lower Guero village in Zimbabwe, we used to slaughter one goat every month. And can imagine an indigenous Matebele goat, live weight 35 kilograms. When it's slaughtered, the meat is about 15, 17 kilograms. With my grandmother, her 8 children and 17 grandchildren, that was our meat supply for the month. So the ration was a fingerling a day for each child. The rest of the meat was dried and would only pull one strip when it was meat day, cut it into little fingerlings, and that's what you picked. I was so sure that when I grow up, I'm going to own my own goat farm, and I'm going to make sure there's lots of goat. When I went to study in Egypt, where I got my first degree, we had 15 options of what to specialize in. It didn't take me much to say animal science, because I wanted to make sure that I can grow more goats. Just when I have more goats and now into cattle production, the good and the bad about livestock is said, and I have to go back to a fingerling, even though I can now afford a large 500-gram steak. This is the topic of our session today: the good, the bad, the ugly about meat and livestock. When you Google these days and try to find out about the subject, a fun exercise I did, meat consumption comes up, human health comes up, planetary health comes up, nutrition, climate change, developing countries, developed countries, greenhouse gases. This is all the subject we are going to unpack today with the eminent panelists of 4 who are all experts in different aspects of this hot topic. For our audience, we are going to be with you for 90 minutes, and we are dedicating the first 45 minutes to each panel, giving us a snapshot of their knowledge on the subject. After the 45-minute mark, we're going to turn to you, the audience, to engage with us in a dialogue. Please start posting your questions now, because this is a hot topic. I'm sure you already came loaded with questions. I'm going to open up for a discussion with our panel as soon as they've finished their presentations, and they will be all yours for you to eat them up. So without further ado, I'm going to ask my panelists to shut off their videos, and I'm going to call upon Professor Martin Kaim, who is going to be our first speaker, to address us on the topic of meat consumption and sustainable development. Martin, you are a passionate economist, and congratulations again on your recent appointment on this platform. I'm keen to hear from you. What is your day job, and why did you curate such an interesting session? You are the curator. Share with us your dream. Start from your day job and unpack meat consumption and sustainable development for us. You have 10 minutes. Over to you. Thank you.
Thanks, Lindiwe. Can you hear and see my screen?
Yes, all good.
Okay. So starting with my day job, I mean, I am an agricultural economist, and I am working on various aspects of sustainable agriculture and sustainable food security. And I think when you're looking at the broader sector food systems, then obviously the question of meat and livestock is one that's very prominent in various ways, and I'm really glad that I can give an overview about several of these aspects, starting from economic, social, nutrition, environmental aspects, and many of these points will be then further discussed in the subsequent presentations by the other panelists and then in the discussion. We're currently writing a broader review paper exactly about this topic, and this is joint work with Martin Palaska. The paper is not yet ready, but will be in the next couple of weeks, and many more details will be in that paper. Let me start off, and now I'm realizing, so, okay, now it's working. Let me start by giving you a flavor of what some of the aspects, how meat and livestock production and consumption are affecting many of the SDG dimensions, actually. There are quite a few aspects where meat and livestock have positive influences on sustainable development economically. I mean, half of the total agriculture production value worldwide is made up of the livestock sector. There are many hundreds of millions, actually estimates say that around 1 billion persons derive at least some of their income from livestock production, and often these are poor and very poor persons. Of course, from a consumer and nutrition point of view, it's meat and livestock products are very important sources of protein and several micronutrients. And when we look at resource scarcity perspective, we also have to see, well, livestock uses a lot of land, but a lot of this land is grassland resources that can actually not be used directly by humans. It's inedible, and therefore it's an efficient use of this resource. But then, of course, there are also a couple of negative aspects, negative meaning that here meat and livestock production and consumption are rather impeding sustainable development. We cannot deny that livestock has a much larger environmental and climate footprint than plant-based foods, also depending on how we're keeping livestock, their animal welfare issues. There is some evidence that high consumption levels, especially of red meat and processed meat, are associated with certain health issues, including some forms of cancer. And also depending on how we're keeping animals, especially when they're intensive systems and close human livestock interactions without proper hygienic conditions, there is an increased risk of zoonotic diseases. So many people are saying we need less livestock. Less livestock would make things more sustainable. Perhaps even vegetarian or vegan diets would be the way to go. Whether or not, and we'll come back to this question, of course, but whether or not, that's something that we would like to see, I think it does make sense to look at the trends of meat consumption over time. And this is here the global trend in absolute numbers broken down by different world regions. And we are seeing a huge increase. I mean, between the 1960s and 2020, meat consumption has been more than quadrupling, actually increases in all world regions. We are seeing here Asia is now accounting for about half of the worldwide meat consumption. Of course, this increase has at least two factors: it's population growth and its income growth. So when people get richer, they tend to consume more meat. And we are seeing here in this graph per capita consumption trends. The dotted line is the worldwide average, a clear increase. And we are seeing huge differences, of course, in poorer regions of Africa and Asia, large parts of Asia. We have still below average consumption levels. And just imagine what would happen if these levels would increase to what we currently see in the richer world regions. That would be environmentally disastrous, probably. But just, so many people saying, well, we just need to reduce meat consumption or become vegetarian, and then the food problem would be overcome, the environmental problem of agriculture would be overcome, regardless of whether it's true or not. But the notion that we can easily move towards vegetarian diets is naive. I mean, when you see those trends, that's something I think we need to keep in mind. Let's look a little bit deeper into some of the environmental aspects. There are environmental problems. I mentioned grass that cannot be used by humans directly. This is true. But we do see in many parts of the world an increase in pasture lands into forest areas, into other natural habitats. It does contribute to deforestation in the Amazon and in other parts of the world. And of course, there is an opportunity cost of that. We also cannot ignore the fact that of the crop land that can be used for human food production purposes, 40% is currently used to produce animal feed, and there is certainly competition. So if all this land were used for direct food uses, many more people could be nourished. And all of this land use intensity has biodiversity and climate change implications. Livestock accounts for about half of all the greenhouse gas emissions from agriculture. We know that agriculture accounts for about 25 to 30% of all the greenhouse gas emissions, and half of this is due to the livestock sector, which includes livestock husbandry, the methane and all that, and it does also include the land use and land use changes due to feed production. This is the production point of view. We can look at greenhouse gas budgets also from a consumer point of view. So consumer asking, okay, if I buy a kilogram of beef, for instance, how does that compare in terms of greenhouse gas emissions to a kilogram of grain or of pulses? And this graph shows how it compares. Of course, these are average numbers and there's a lot of variation, but I think the overall picture becomes very clear that all the livestock products and meat in particular produce much more carbon dioxide equivalents than the typical plant products. Now we can argue, yeah, okay, but of course, when you compare grain with meat, then the nutrient structure is very different. There's much more protein and micronutrients in the animal products, and that's not accounted for in this picture. Well, let's look at a different version of this picture where we look at the greenhouse gas emissions per 100 gram of protein. And the concrete numbers change, but the overall message doesn't change, that the animal products and the meat in particular is more intensive in terms of greenhouse gas emissions. Now, some of the emissions come from carbon dioxide, other parts come from methane, and methane, as many of you know, is different. It has a very high climate change potential in the short run, but it's much more short-lived in the atmosphere. And this is something that's not fully accounted for in these types of graphs. We can say, well, it's difficult to really find the right calculation for methane into carbon dioxide equivalents. But for simplicity, just leave out methane completely from the picture. The overall conclusion doesn't change dramatically, even without considering methane. The greenhouse gas emissions from livestock are much bigger than those from plant-based products. So from a mere climate perspective, we should be vegetarians, we should even be vegans. But the thing is that climate is not the only thing. It's important, but it's not the only thing that matters for sustainable development. And there's plenty of evidence that meat consumption is associated with better nutrition in many situations, and especially so in developing countries. Not necessarily very high levels of meat consumption, but low to moderate levels, there it's true. This is a very simple graph showing a correlation between rates of child stunting, these little dots here per country, and rates of meat consumption. And we see there is an association. The more meat is consumed, the lower are the rates of child stunting, or in other words, the better is the child nutrition situation. Well, this is a pure correlation. It's not necessarily causation, but there is increasing data, and we'll hear more about this from Derek Hede, showing that even controlling for a bunch of possibly confounding factors, it remains that association that meat and animal product consumption is associated with better child nutrition. Now, does that mean that plant-based diets cannot be healthy and we cannot do without meat? No. That's not what it means. Healthy plant-based diets are definitely possible in many situations, if you have the knowledge and if you have the year-round access to healthy diets and fruits and vegetables and all that it takes. And unfortunately, the situation is not given in many poor regions. There are income constraints, there are knowledge and awareness constraints, there are seasonality constraints, and so on and so forth. And that's the reason why, from a nutrition perspective, promoting vegetarian or vegan in some situations at least is not necessarily the best thing to do. What's the bottom line? Low to moderate consumption of animal source foods is something that is compatible with sustainable development, and we need to have a differentiated picture. It's not black and white. It's not only good and bad. Many of you are familiar with the Eat Lancet Commission recommendations. This is the flexitarian version, which is showing for different food groups here how much could be consumed, aligning human health and planetary health. So this dotted line of 100 would be what would be possible even for 10 billion people on our planet. But we see that in many parts of the world, especially in the rich parts here shown for North America, we are overshooting, we are overdoing. So much more than is good for planetary health and even for human health, whereas in some of the poor regions, in Africa in particular, we're actually underdoing. And that's the clear message here. Dietary change is important for human health and for planetary health, and that means less meat consumption in the rich world on average and more animal product consumption in some of the poor regions. The important question that we certainly need to ask ourselves as economists, and it's an important research topic for the future, how do we get there? How do we actually induce such dietary change? What are the right policy tools? What are other tools that can be used? And with this, I thank you and hand over back to our chair.
Thank you very much, Dr. Martin Kaim, for that exciting overview. Lots of questions coming up your way. There are people who have no choice, and you have eloquently defended what we have on the table and where we have to move the graph to. We are not going to give you any questions now. We are going to have all the presentations and come back to you. Allow me to now call upon Derek Heddy, who is going to address us on livestock and human welfare in developing countries. Derek, welcome to the panel. What is your day job, and what gives you authority to talk about developing countries and welfare issues? Over to you.
Thank you, Dr. Lindiwe. So I'm also an agricultural economist. I'm the second one on the panel. My research interests, certainly overlap with Methane a little bit. So I work on agricultural economics, but I particularly work on how to use agriculture to improve nutrition in developing countries, mostly in South Asia and Sub-Saharan Africa. And for the last maybe 7 or 8 years now, I've been leading a project for the Bill and Melinda Gates Foundation and the CJR on advancing research on nutrition and agriculture, or ARENA. And so a lot of what I'm going to be talking about today is work from ARENA with many co-authors like John Hodenot, Kalle Hironen, Bellew Haile, many others, and Jones. We've been trying for years to try and understand not just livestock, really, animal source foods in general and their impact on nutrition, but also a little bit on livestock rearing and its association with nutrition outcomes. I'll leap right into that. I'll mention we also look at fish, but I won't talk much about fish here. So a little outline. Big question I'm going to look at is, are livestock products linked to stunting? Stunting is not everything, it's a good cumulative measure of chronic malnutrition, but it's a measure that we have available. And it's also important, I think, in future work to look at micronutrient deficiencies and other measures of nutrition outcomes, as well as cognitive development. And so I'm going to talk about some of the different forms of evidence we have on actually animal source foods and stunting, not just livestock products. And then I'm going to look at a question on how does animal source food consumption vary across countries and why. I think we'll see some expected, but also some surprising cross-country patterns among young children in particular. Most of our focus is on young children. And then we're going to look at some of the explanations. Obviously, income is one that Martin mentioned. But another area that we've become very interested in is relative prices, and this idea that the relative price of animal source foods varies across countries and has explanatory power, even controlling for income and other factors. And then thirdly, think about what can we do to improve animal source of food affordability. And if I get a bit of time, I might also comment on some issues around sustainability, but we can handle that in the panel. So firstly, on stunting, why do we look at child stunting? And why do we look at such a young age group? Many in the audience might have heard the phrase first 1,000 days, which really refers to conception to age 24 months. And this is a graph that shows that in 49 countries, developing countries, the expected prevalence of stunting by age, very young age. And you'll see if you look at essentially the y-axis intercept, almost 20% of children in these 49 countries were born stunted. So that means they suffered from malnutrition in the womb, essentially, or their mothers suffered from malnutrition. And then what you see is actually sort of a flat line up to 6 months when most children in developing countries are breastfed, and then steeply rising stunting rates until around 24 months. So that's really striking. 20% of kids born stunted, massive increase from 6 months onwards. And then there's no sort of population level recovery after 2 years. But you might also say the first 3 years is actually a really important window as well, because there's a lot of cognitive development going on in that time. And the diet contributes quite a lot to cognitive development as well. So that's why we look at young children. And one thing we're really trying to understand is, why do you see this really steep rise in stunting from 6 to 24 months? And of course, also why are so many children born stunted? So why are kids born small and underweight? As I said, poor maternal health and infections, poor maternal status, maybe they're too young, too many children, poor maternal diets, low animal source foods could be an issue there. And then why do kids start to fall behind at 6 months? Poor health. Kids at 6 months are crawling, walking around. They have weak immune systems. They can become highly exposed to infection, especially even from foods, because they're no longer exclusively breastfed usually. So health is a major factor, a non-dietary factor in some sense, but it could be related to diets. And then we have this big issue around poor diets and feeding practices. So after 6 months, there are rising nutrient needs for infants that are no longer being met by exclusive breastfeeding. So breastfeeding is great, but you can't just keep doing it forever. And then young children also have what I like to call a sort of small stomachs problem. They need really nutrient-dense foods. They can't get too many feedings a day. You can't get too much into them. But actually what happens in many developing countries is they're fed rice or corn or some kind of watery gruel that's not nutrient dense. It may sort of give them a satiation, but it's not nutrient dense. So they really need nutrient dense foods. And a key point I would like to make about animal sourced foods is they are a multi-nutrient dense food. So they're not just dense in high quality protein, they definitely are, but they also have micronutrients and highly bioavailable micronutrients. So sometimes when people refer to animal source foods, they're just called a protein and they're lumped together with legumes and nuts, but actually their nutritional profile is quite different, and that has important implications for child diets especially. So I don't think it's the case that animal source foods are just a substitute for other quote unquote proteins like legumes or nuts. And I think that's a really important point. And then another key feature of animal source foods is they're typically tasty. In the case of milk and dairy products, they're familiar for young children because they're used to breast milk. So it's quite easy to get a child to eat significant quantities of milk, of cow's milk in particular. And so they can generally be very attractive first foods. And anybody who's had a kid knows it can be quite difficult to get children to eat what you want them to eat. So what's the evidence on animal source foods and stunting? I would say it's sort of diverse, messy, but broadly consistent. And there's different types of interventions. So we have nutrition interventions where we're basically feeding animal source foods to kids. And actually there's surprisingly few of these. We have nutrition sensitive livestock interventions. So this could be giving people a cow or a goat and often giving them some sort of nutritional advice. And then we also have observational studies on livestock ownership. So we've done a few of these in the ARENA project, sort of examining, do households that have cows tend to have children who are less stunted? And we try to obviously control for confounding factors or do something quasi-experimental. And then a very different literature that most here would not be familiar with are historical studies on adult heights and animal source food production, also genetic studies on adult heights that have strongly linked adult heights to lactose tolerant genes, because dairy is thought to be particularly associated with linear growth. So very diverse studies. And then we've also engaged in a large observational study on the demographic health surveys from 49 countries that's published in IAAE. And that looks at animal source food and consumption and stunting, in a really large set of countries. So what does the experimental feeding literature sort of suggest? There's been a recent Cochrane review, focuses on kids 6 to 59 months. There are some other studies coming out, but really there are very few studies covered in this review. And, one in China, one in Ecuador, there was another one in China, and then in some mixed developing countries. You see sort of mixed effects, but there's a few things to note. There's still very few experiments in developing countries. It's a limited set of animal source foods. There's no milk, even though milk is maybe the product that's most strongly linked to stunting, I would say. No fish, no chicken meat. There have been some updated egg studies as well that have had sort of, mixed results. And then one of the studies compares to fortified infant cereals, but that's not a sort of baseline food in most poor countries. It's rare to see those consumed. So then the study I was referring to before, animal source foods and child stunting, we use what I like to call the Napoleonic method. Napoleon said quantity has a quality all of its own. So we use a really big data set, 300,000 children from 49 countries, very diverse. And of course, the statistical analysis tries to net out as much as we can. We try to net out household wealth, parental education, health services, demographic, geography, etc. So a few findings here. The first is that so we try and look at older children because those would have benefited most from sort of prolonged periods of animal source food consumption. When I say older here, older within that first 1,000 days range. So we're talking about kids 18 to 23 months. And we find that consuming any animal source food reduces the risk of stunting by about 4 points. Now that may sound small, but actually in the context of stunting, that would be a pretty good result. Most RCTs, etc., would be very happy with a 4-point reduction in stunting. But that's just any animal source food. When we break up animal source foods, we see some interesting results. They're all significant, but dairy seems to have a somewhat larger association at 3.4. And then there's several case studies that find even larger effects for dairy when using sort of more experimental approaches. So we think that's an interesting result. And then we also tested having multiple ASFs because ASFs have different nutrient profiles. For example, dairy has a lot of calcium. It also has an insulin-like growth factor 1. So it's a hormone thought to be associated with linear growth, but it doesn't have iron, for example, and meat and fish and can have more iron, for example. And we find that having multiple ASFs seem to complement each other, and that can lead to roughly a 6-point reduction in stunting. So that's quite a large effect. And that suggests that animal source foods could really contribute quite a bit to stunting reduction. And then a sort of fourth result linked to other research that I mentioned is that we have several studies now using more and more sort of quasi-experimental approaches linking milk production or consumption to stunting. And some of those effects really are quite large, not always precisely estimated, but quite large. And I'll just mention there, actually, we have a presentation tomorrow around lunchtime, trying to use a global cross-country panel, trying to link growth in milk consumption over time at the country level to national changes in stunting. And there too, we find this large effect of dairy in particular. And I'll also mention both of these studies actually find similar associations for fruits as well, even though we don't mention that too much. So livestock has these positive effects, but some formative research has found that being exposed to livestock on the farm can actually have negative consequences. A study in Zimbabwe actually observed young children consuming chicken feces. Poultry are also linked to chest infections, and in ARENA we conducted 2 studies looking at these issues. In Ethiopia, we found that when poultry were kept in the main household dwelling, children were more likely to be stunted. There's another study unrelated to ours, very similar finding in Bangladesh. And then in Ethiopia and Bangladesh, we found that household compounds where enumerators observed animal feces had children that were also more likely to be stunted. And about 40% of households had animal feces around the household. So, it's actually potentially a pretty big thing. I mentioned, though, that a lot of follow-up studies haven't really been able to replicate these, although they often do show widespread sort of microbiological contamination from livestock fecal matter. So that second question, how do animal source food consumptions vary around the world? Well, they're very low in developing countries, but we also see mixed results. So in Western and Central Africa, those are really fish-dominant areas, whereas in the East African highlands, it's much more dairy, and then the rest of Africa, a little bit more mixed. South Asia is interesting again. India, dairy is hugely important in India, but in countries like Bangladesh, it's fish again. So a lot of the developing world, you can sort of divide into a sort of dairy-fish dichotomy. And then in the wealthier regions, Southeast Asia, Latin America, etc., much more diversified, and you even see high egg consumption. So, quite interesting patterns of animal source food consumption. Why do we think this is? Well, often people think it's, okay, nutritional education. Is it just low income? Africa is certainly poor, and poorer kids consume fewer ASFs, but of course that doesn't explain why some places consume dairy instead of fish. And then in another study, we tried to look at how costly are eggs versus rice calories, how costly are fish calories versus rice calories, etc. And we used a large global data set from the International Food Comparison Program to do that. And we measured these relative caloric prices. And the basic story there is that animal source food calories are much more expensive in low-income countries. Dairy is cheap in a few places like India, Latin America, Eastern Europe, and Central Asia. And fish calories are relatively cheap in West Africa and Southeast Asia and China, which explains why we tend to see fish consumed in those places. And then a really striking result, people are very excited about eggs for a while and nutrition, but egg calories are super expensive in Africa. And, that's really no surprise. These relative prices seem to do a good job of explaining animal source food consumption patterns. We have some econometric work showing that. I'll almost finished here, but, basically, why do we think animal source food prices are high or low? Well, simple sort of trade model, there's two types of products, right? There's long distance tradable or blue ocean tradable products. They can be frozen or dried. Fish is really interesting. It's often dried or smoked in Africa and Asia and can be transported long distances. And then you've got short distance tradable where prices are set locally. So poultry productivity is really low in Africa. That's why egg prices are so high. Fresh milk prices can also be very high and tend to be very high in Africa as well. And so we see really low consumption of dairy and eggs in much of Africa and parts of Asia as well. So what can be done to improve animal source of foodability? I think operating at scale, there's been a lot of small scale projects, but we really need to think about how can we increase the access to animal source foods at scale. Need to think more about animal source food consumers and not just producers. So I think this is an important point, especially for agricultural economists. We've done so much to look at production, but we really need to think about how can we change things on the consumption side. I give a few examples there, school feeding, supplementation, etc. And we actually have to think about industrial policy and trade and not just farming. So East Asia has a very interesting dairy story that involves some amount of production, but still a huge reliance on dairy powder imports, and then sort of mixing powdered milk imports with local supply. And I've just shown a picture there of a company called Vinamilk Milk in Vietnam, which is, they're sort of an astonishing success story where, they consumed almost no dairy 30 years ago, and now it's, starting to become a high dairy consumption country, especially among kids. And of course, we have to solve a lot of sort of domestic value chain problems for these perishable foods. And then in some countries, there might be binding demand constraints. And we need to think again about how to foster sort of more demand at scale. So I'll stop there and look forward to answering questions a little later on. Thank you.
Thank you very much, Derek. You've taken us from production, consumption, health, particularly the stunting issues, and also the policy component. How do we make sure those who cannot access those animal source foods can produce locally, but more important, improve access, particularly to children? We'll come back to you with questions. Allow me to move to Frank Midlena, who's going to address us on livestock, climate change, and the environment. Can we take a deep dive, Frank, into those issues? Tell us what your day job is and what gives you authority to be addressing us on these issues. Over to you, Frank.
Well, thank you so much. And hello, everybody. My daytime job is, I'm a professor and air quality specialist in the Department of Animal Science at UC Davis, and I research the environmental footprint of livestock and ways to mitigate those impacts. And today I will talk to you about mainly greenhouse gases and impact of livestock on climate and how we might reduce that. So when it comes to greenhouse gas, one really important aspect is how we quantify greenhouse gases. And here, a unit that's now almost 30 years of age, called GWP 100, is widely used, and it compares methane and nitrous oxide using a factor called the GWP 100 to CO2. And indeed, methane is a potent greenhouse gas and one that we need to seek to mitigate. There's no question about that. Yet there are other differences between methane and other greenhouse gases that are very important to consider. And the reason why this issue is so relevant is because methane is a very critical greenhouse gas, the Achilles heel of animal agriculture, and one of the keys to resolving our climate issues. So the GWP 100 says methane is 28 times more potent in trapping heat from the sun than CO2. But as I said, there's more to this story. On this slide, you see the global methane budget. On the left side of the slide, you see various sources of methane, including agriculture, but there are also some others. But on the right side, you see that there are also sinks. While all the sources globally amount to approximately 560 teragrams of methane, sinks amount to 550 teragrams of methane. And that means there is an important atmospheric removal process called oxidation. And this oxidation process is largely not considered when using GWP 100, the unit that's currently used to quantify greenhouse gases. Why is that so important? This atmospheric removal has everything to do with how how long these gases stay in the atmosphere, the so-called lifespan of these gases. While, let's say, CO2 is in the air for 1,000 years, methane for a little over a decade. And that has everything to do with this atmospheric removal process that I talked about just a minute ago. So just really briefly, in 10 minutes, I can only do so much. The difference between a long-lived climate pollutant like CO2 versus methane. Every time we burn fossil fuel, gas, oil, coal, we add new additional carbon to the atmosphere. Carbon that is ancient carbon that was stored in the ground for very long is burned, and we add it to the atmosphere, and that makes CO2 a stock gas. It accumulates, it's additive. And currently methane is, in the international policy world, treated as if it also were a stock gas, as if it were also to accumulate in the atmosphere, when indeed it's not, because there's this atmospheric removal process, making methane a so-called flow gas. What this means, and you can read this up in the recent IPCC report, is that because there's this atmospheric removal, a constant source of methane will not add to additional warming. Constant source of methane will not add to additional warming, and that means a constant, let's say, cattle herd will not add additional warming to our planet. Increasing methane rates do lead to additional warming, and we must stop those from occurring. But what's also very interesting is that when we reduce methane, beautiful things can happen, as will be shown on the next slide. Here I will walk you through three different scenarios where over a period of 30 years, in the first scenario, methane increases by 35%. This actually happens in part of the developing world where livestock herds are growing, emitting increasing amounts of methane. The second scenario is one where methane is held stable over 30 years, maybe slightly falling. The third is one where methane strongly falls by 35% through mitigation activities. So how would these three scenarios, the increasing, the stable, and the decreasing methane scenario, be depicted using this old matrix of GWP 100 for methane? GWP 100 would predict that in all three, increasing, the stable, and the decreasing methane scenario, we would add significant amounts of additional CO2 equivalent greenhouse gases. We know that that is not the case because methane is not just produced, but also removed. So the second scenario is clearly flawed, and the third scenario even more so. So a new unit was devised from colleagues from Oxford University called GWP star. And this unit actually does take into consideration not just emission sources, but also emission sinks and atmospheric removal. This new unit is called GWP star, and it has received a lot of attention, also in the most recent IPCC report that came out last week. How does it compare to GWP 100? Well, in the increasing scenario where methane increases over 30 years, GWP star and GWP 100 are very similar. But when methane is held pretty stable or even slightly reduced over 30 years, then you see that there is no additional warming occurring, and that is evidenced here by no blue north of the x-axis, meaning you actually see there a negative sign in front of the number -10, and that indicates that we have a slight reduction of carbon from the atmosphere, which is referred to as negative warming. And that's a good thing because you're now pulling carbon out of the atmosphere. If you manage to strongly reduce methane, as is the case in the third scenario, then you are pulling a lot of carbon out of the atmosphere, similarly to planting trees. Okay, so strong mitigation efforts in and around methane offer a significant opportunity in reducing warming and indeed inducing cooling. And that is evidenced here in the third scenario. And as you can see, GWP 100 and GWP star are drastically different in the stable and in the decreasing scenario. So please remember this third scenario here, the fall by 35% in the bottom scenario, because I'll get to that in just a minute. Why does all that matter? Why do we care about reducing methane? Well, one of the reasons is what everybody calls the 2050 challenge, which is depicted on this slide. On the x-axis, you see the year 1750 to 2050, hence the name 2050 challenge. And on the z-axis, you see human population increase throughout the world. I was born about 50 years ago, and at that time we had 3 billion people in the world. Today we have almost 8, and by the time I will be an old man, we will have 9.5 billion people in this world, meaning throughout my lifetime, human population on this planet will have tripled. Tripled, but natural resources to feed these people will not have tripled. By the way, a significant portion of this population increase is due to increasing life expectancy, more so than just growing family sizes, increasing life expectancies. So we really need to think about how can we reduce greenhouse gases, and that of course includes the agricultural sector. The slide is one of my favorites. It shows pretty drastically a circle of Southeast Asia containing more people in it than the rest of the world combined. More people live inside the circle than outside the circle. Clearly one of the hotspots for food security, but not the only one. Africa is at least as big, if not even more, a hotspot for food security. We see meat consumption is growing in different regions of the world. We saw it from one of my earlier colleagues, particularly in Asia, increases are drastic, but other regions of the world are similar. Most developed countries are relatively plateaued, but globally the increase of consumption is projecting upward. So we have to think about how can we keep environmental footprint of the livestock sector at bay, particularly when looking at how emissions vary throughout the world. On this slide on the x-axis, you see milk production per cow per year, from low producing cows on the left to high producing cows on the right, and the y-axis shows the carbon footprint per unit of milk produced. And each diamond shows one country and its dairy production intensity. And you can see there are many countries where milk production per cow per year is dismal, where a cow produces 1,000, maybe 2,000 kilograms of milk per animal per year. Whereas in most developed countries, milk production per cow per year is close to 10 tons. And as you can see here, emission intensity and production intensity are inversely related. When the one goes up, the other one goes down. And so there's a lot of room to grow. The IPCC suggests that 70 to 80% of global greenhouse gases associated to the global livestock sector occur in developing countries. This is not finger pointing. This is just saying there are many regions where emissions are very high, largely as a result to very low productivity rates. This is an FAO slide. Here on the x-axis, you see different regions in the world. On the y-axis, the greenhouse gas footprint of milk production, and you can see a large spread in and around different regions of the world, clearly indicating that there is room to grow and to improve. How can we improve it? Well, here are 4 bubbles: reproductive efficiency, the veterinary system or sector, genetics, as well as the feed sector. All are very important to decrease number of animals to satisfy the nutritional needs of a given population. In my opinion, livestock can be an important part of a climate solution, particularly if we reduce methane. And if we reduce methane strongly, incredible things can happen, as we have recently found here in California, where a new law that has mandated a 40% reduction of methane has triggered new innovations. For example, the covering of lagoons where manure is stored, where the gases are now not off-gassing into the air, but they are trapped under top. And then the so-called biogas is converted into fuel, converting what used to be a liability, which is the emission gas, the so-called biogas, into an asset which is a fuel type that's now going into vehicles like semi-trucks. This conversion over the last 3 years here in California has led to a 25% reduction of methane that is now certified by the state. So over halfway of this 40% reduction goal has been achieved, and it shows that these reductions are possible. And what's really meaningful here is that a strong reduction of methane can lead to negative warming, i.e. cooling, counteracting nitrous oxide and other gases such as CO2 to a point where the livestock sector, the dairy, for example, sector, can reach a point of climate neutrality, a point where at some point in the future, that sector does not contribute to additional warming. And this is what we are striving for, not just here in California, but throughout the United States, as well as other developed and developing countries. So with that, I come to a close, and I'm looking forward to entertain any questions that you might have. Thank you so much.
Wow. Thank you so much, Frank. And ending on that positive note, livestock production can be a solution to climate change if we do our maths right. Thank you very much. Now, we're moving to our last presenter. Jessica Fonzo is going to be speaking to us about meat and livestock sustainable futures. Jess, what is your day job?
Great, thank you so much, Lindiwe. It's great to be here. My name is Jess Fonzo. I am a professor at Johns Hopkins, and I'm a nutritionist by training. And I will be finishing up this round of great presentations. It's always hard to go last when you've had so many stellar presentations before. Let me share my screen. And I was asked to talk about sustainable futures. Where do we go with all of this rich data that's been presented? So some key questions that we have for the future are things like, how much meat should we produce and consume? How much should we be consuming? What alternative sources of protein and micronutrients can help towards healthy and sustainable nutrition? And what political, technical, and societal changes are needed? And the answer to all of this is, it depends. Depends on who you are, where you are, and your income and your tastes, your culture. So it really, your livelihood, it really depends. So let's start first with this idea that there's been a lot of studies showing that food systems are contributing to global greenhouse gas emissions. We know this. The numbers vary depending on the research and who's published the report, but it's centered around 30% of total greenhouse gas emissions is coming from food systems. And it's not just livestock, it's not just beef, it's many different sources and actions across the food system that are contributing to the greenhouse gas emissions. Land use changes, feed, different varieties of crops produce different greenhouse gas emissions depending on where and how they're grown. Livestock, fish farms, retail packaging, transport, they're all contributing to global greenhouse gas emissions. And it's important to note that what would it take to reduce greenhouse gas emissions coming from food systems? When we look at a business as usual, if we keep governing and taking steps towards what is a typical food system response, we're going to continue to produce a significant amount of greenhouse gases, overreaching the 1.5 degree Paris Agreement, overreaching or peaking at 2 degrees or more. But if we look at different actions, things like high yielding varieties, which of course would mean significant bioenergy transformations in crop genetics and management processes, half food waste, cutting food waste in half, people consuming healthy calories, meaning they're consuming enough calories to stay within a normal quote, normal body weight, best farm practices, things like better management of fertilizers, and a more plant-dominant diet. You can see the reductions in greenhouse gases with different degrees of reduction. But on the bottom is the green, in which if we partially took all of those different responses, high yields, healthy calories, better farm practices and management, and more plant-based diets, we would get to the 1.5 degree target. And if we fully did those 5 interventions, we'd have significant reductions in greenhouse gases. And this goes to the point with Methane, when he earlier spoke that it's not just diets that's going to make the impacts, it's a whole range of actions and tools and innovations that we need to make significant reductions in greenhouse gases coming from the food system. So what about meat? Well, if you want to start a fight on Twitter, tweet #AnimalSourceFoods. It's an incredibly contentious topic. This diagram is showing you the Eat Lancet Commission. I was a part of that. Also a very contentious commission and their results and recommendations. And this is showing you in the orange boundary the Eat Lancet recommended diet compared to what people in North America consume. So you see a lot of red meat, starchy staples, eggs, poultry, dairy foods, as compared to sub-Saharan Africa, which is staying within the health boundary, with the exception of starchy staples, which makes up a lot of the African typical diets of Africa and West and East and Southern Africa. And in both countries and regions, not enough of the healthy foods, fruits, vegetables, legumes. But what this diagram shows is incredible inequities of who gets access to what kinds of foods. And Derek eloquently talked about that and the why. Just to drill down a bit more, this is showing you the recommended intakes of animal source foods in the Eat Lancet diet as compared to average daily per capita animal source foods, but this is showing you supply data. So coming from the FAO balance sheets. And you can see the Eat Lancet there in the middle. You can see the United States on top. We consume a lot of dairy, a lot of red meat, a lot of chicken. India is very close to the Eat Lancet diet, a lot of dairy, but very little of the other foods. And it goes a bit to Derek's insights into dairy being less expensive in India. And you can see in places like Kenya, Senegal, Ethiopia, much less animal source foods overall compared to US or the UK or Brazil, but things like eggs, again, very expensive as Derek had highlighted, and other products. So you can see just massive inequities, not only in the amounts of animal source foods, but the types, and a lot of that having to do with the cost. So what do we do about these inequities? And I think, Frank talked about some of the science and path forward. Derek and Methane talked about the nutrition and environmental issues. So what do we do about this very complex, very controversial topic? Can we make changes? Maybe some of you know this is Sam Cooke saying eloquently about questioning, is a change going to come? Well, I'm going to highlight 5 things and then some paths forward. One, we need to ensure that this idea of healthy and sustainable diets, that they're affordable. And Derek did some of this work along with others at Tufts University, showing that the Eat Lancet diet in green is quite expensive as compared to a diet made up of starchy staples shown in gray, or a diet that meets nutritional needs, a nutrient adequate diet. And even a nutrient adequate diet is incredibly expensive. The FAO SOFI report showed that 38% of people cannot afford a healthy diet. Well, the Eat Lancet diet, a very plant dominant diet, is unaffordable for a significant proportion of the world's population. Another thing we need to consider when we think about solving this conundrum is what is consumed and what's being pushed, what sectors of the food system are growing. And some work that we did this past year, led by Tom Reardon, showed that in sub-Saharan Africa, there's a significant growth in the processed food sector. A larger proportion of people's diets are made up of these highly processed, or what's also called ultra-processed foods and drinks that are high in added sugars, sodium, and unhealthy fats. And you can see this is a diagram showing you across the regions of the world, this increase in ultra-processed foods in most regions, as well as drinks, sugary beverages. With the exception of North America, you see actually a decline. But when you look at North America's overall in volume consumption of ultra-processed foods, it blows every other region out of the water. But there's been a flattening of the uptake of those foods. But this is what people are eating. Very convenient, tasty, low in cost, highly processed foods that have been linked to poor health outcomes and increased risk of obesity. And one thing we know very little about is the environmental impacts of these ultra-processed foods. This was a paper in the Lancet Planetary Health Journal questioning, do we know enough about the environmental impact of these foods? We're learning more and more about the health impacts, but this is a bit of a black box. Another thing we need to consider is what motivates dietary change. Does climate change affect food purchasing behaviors? And is environmental sustainability a motivation for behavior change among food system actors, but also consumers? Do we know people living in different places in different contexts, are they aware of the environmental impact of the foods they buy? Does this awareness affect their food choice? Does it bolster and hinder the healthiness of their food choices? If we think about big drivers of food choice, taste, price, convenience, and safety, does environment fit into that, into those drivers? And others have shown that the demand for animal source foods is significantly rising since the 1960s. You can see China lit up there, as well as other Asian countries. As people get wealthier, they tend to want to consume these luxury foods like animal source foods. Another issue we need to consider is understanding which options are ethically permissible and acceptable. Will people want to eat insects? Will people want to eat lab-grown meat? Will people even want to eat these highly processed alternative products like Beyond Burger and Impossible Burger? These are big questions that we have to deal with. And much like the genetically modified organism backlash that many consumers are fearful of, lab-grown meat could fall into that same category. So we need to be thinking about some of the ethical challenges around these kind of alternative proteins and foods and alternative sources of foods beyond just protein, as Derek had said. And then another big issue is the massive changes we would need to make in agriculture systems. This is showing you in yellow, business as usual 2050, still wasting 30% of all the food we produce, compared to people consuming the Eat Lancet diet in green and having food waste by 2050. So this is showing you if everyone were to eat the Eat Lancet diet in green, this is what agriculture production systems would have to change towards. No increase in cereal production. Any of you who've worked in the CGIAR know that that would be a very different shift in what is funded for R&D. Significant increases in producing vegetables and fruits. Daniel Masson de Cross published a paper showing that we don't even meet the 400 grams per capita of fruits and vegetables in the current supply chain. We'd have to increase fish, legumes, nuts significantly, and we'd have to see a decrease in red meat production by 65%. This has significant impacts politically, significant impacts from a livelihoods perspective, and those that earn their incomes around the livestock sector, would be massive. So we need to be thinking about those things. So can everyone win? Well, it depends. It depends on a lot of things. What system, what diet, what substitutes. We need to be thinking about the livestock sector and the diverse livelihoods that are born out of that sector. Alternative proteins. This idea of now it's our turn to eat meat. Lindiwe knows this very well. In Africa, with the rising middle income class, they now have appetites for more animal source foods because they can afford those. It's their turn now. The question is, will there be anyone's turn with the way climate change is going? So deserved, but is that realistic? People arguing that when I eat a paleo or keto diet, I've never felt better. So why are you asking me to reduce that? Is this personalized health perspective? And issues around deforestation and biodiversity threats. There's so many issues that spring from this topic that are ripe with controversy, political, ethical, and livelihood conundrums, and health and environment conundrums. Something that we worked on that Chris Barrett at Cornell led was looking at innovations and what it would take to make big shifts in agri-food systems transformation. And we looked at different innovations. For example, I've put up here replacement food and feed and some social innovations, showing you where they are in the spectrum of R&D and what it would take to transform those innovations into different realistic options. And it's not just the innovation in technology, it involves a lot of political context as well. And some further work we did was looking at trade-offs of some of these innovations across different sustainable development goals. Every innovation, every political action taken has positive impacts and negative impacts. And we need to consider and provide policymakers the trade-offs if they go one way or another. And my last slide is, there's an elephant, or in this case, camels in the room, and there's multiple camels in the room to deal with this very controversial topic. It is a highly debated topic right now in the UN Food System Summit, with a lot of fighting going on about a path forward for member states to take action. We need a supportive political environment to be able to deliberate on these trade-offs issues. We need to cut through worldviews and ideology of the scientific landscape. It's very hard for a newcomer to come into this area and try to understand who sits on which side, because even in the scientific world, there are sides, there are biases, and it's reading that literature and understanding that is incredibly challenging. We need to mitigate conflicts of interest and power asymmetries in research and among industry players. The livestock sector, for example, in the United States, as Frank knows, is very powerful. There's a lot of vested interest in livestock systems. How do we deal with those issues in relation to a path forward? We need to consider issues of context and equity, realizing there's not one size fits all. There's lots of different animal systems, and within that, many different livestock systems. There's many different people on the planet. They live in different places and they have different needs and aspirations. So it's very difficult to come with this is what we need to do and the world should adhere to this. There's so many different contexts that can impact equity issues. And then we need to realize that we're running out of time. We need to make big changes to food systems. The IPCC report made that very clear. So while we're dealing with these multiple camels in the room, we're at a point where we need to quickly resolve these very contentious issues if we want to create a path forward and mitigate climate change. And I'll end there. Thank you very much.
Thank you very much, Jess. And I think my big take home is we are running out of time and we need to make big shifts. Where do we start? with all these biases and polarization in the critical debate, which is really looking at the future of meat and livestock. Colleagues, thank you very much for coming back live. We are now going to go into the discussions. We're going to address the questions that have been provided. The first question that we have online is for you, Martin. Why is it that, and I suppose Frank can come in there, poultry have a lower footprint as compared to other livestock, and when it comes to greenhouse gases?
I can start in 2 sentences, and then I'm sure Frank can give many more details on that. But there are 2 reasons in particular. I mean, first of all, ruminants like cattle and goats and sheep have a very different digestive system, and they produce quite a bit of methane. And that's what Frank talked about in detail, and that's what's driving part of the picture. The other reason is that the feed conversion ratios, and certainly that's not unrelated to the digestive parts, but are quite different. So when you feed cattle on grain, you may need at least 5 and up to 10 kilograms of grain to produce 1 kilogram of beef. And for chicken, this is rather in the range of 1 to 2 kilograms of grain to 1 kilogram of chicken meat under good conditions. And that certainly also contributes to the differences in the greenhouse gas emissions. But I'm sure Frank has more technical details. Frank, do you want to come in here?
You summarized that very, very well. I mean, ruminants are very unique insofar that they can utilize non-human edible, for example, cellulose, and convert that into animal source foods. So this upcycling of nutrients comes at a cost, though, because the cost is that in the rumen, in this very large stomach that these animals have, are microbes, and these microbes produce methane. And the methane is what's then belched out. And ruminants do that, poultry doesn't. And that's a big, big difference. But on this efficiency issue, we also have to consider the difference in intakes of what ruminants eat versus what monogastric animals eat. With ruminants eating largely a diet that is low in nutritional quality, and so they are upcycling more than monogastrics do. But again, the unintended consequence is methane, and that's why they always rate higher with respect to their carbon footprint.
We are going to go back to that methane story. That was an interesting presentation you gave us, Frank. But let's take up the question that's come up on trade issues. What is the role of international trade in addressing the negative environmental impact of meat production whilst bringing meat products to poorer areas of the world? Economists in the room, do you want to have a go at that, Derek? Martin, over to you.
Derek, should I start or you want to start?
Yeah, go ahead, Martin. I have a few thoughts, but go ahead.
That's, of course, a very broad question, and it's difficult to boil down. I mean, first of all, for many of the more intensively produced animals, because of breeding, because of technology, efficiency is much higher in temperate zone rich countries than it is in poorer regions and tropical and subtropical climates. That's what Frank also reminded us of. And for that simple static reason, it could make sense, to have production in one place and trade it to others. And I think that's happening, and that's certainly important. But we need to consider, first of all, that technological progress is urgently required also in those parts of the world where we don't have that yet. Secondly, trade can bring about quite a bit of unintended environmental consequences. Just look at the heavy meat production regions in parts of Europe, a lot of soybean imports into Europe. Contributing on the one hand to deforestation in the Amazon area, on the other hand to serious nitrate pollution problems in Europe and then coming to other places. So I think the bottom line is that trade and to add on that, I mean, we have a lot of emotional debates also about poultry exports from Europe to Africa, destroying markets in Africa, and so there. And I'm not saying all of this is true. I'm just saying there lots of aspects to consider. So the bottom line, I think, trade is certainly important, but the notion that we could produce it all in one part of the world and trade it to the rest of the world, I think would be leading to other types of problems. So I'm not sure whether Derek has some other things to add here.
Yeah, I agree with Methane, and I think it's a complex issue. 20 odd years ago, colleagues at IFPRI wrote a report called The Livestock Revolution, and one of the key findings there was that many transforming countries, developing countries were adopting, especially the poultry technologies that had been developed in Europe and the US, large scale, if you like, poultry factory farms, poultry in particular, because there are huge economies of scale in poultry. So, from a cost perspective, a mega farm producing 50,000 birds is far more productive than a small commercial farm producing 1,000 birds, and it is far, far more productive than a village, farmer producing 100 birds a year. And that technology is reasonably simple. The poultry technology, as Martin mentioned, chickens are pretty efficient at converting feed into meat, and the technology to sort of develop these commercial farms has been pretty successful, and that's happened in Latin America and large parts of Asia and India as well. One of the interesting facts, if you look to sort of update that report that my colleague Channing Arndt has noted, is that Africa's kind of missed out on that revolution. And as he mentioned, Africa is importing a lot of poultry and actually a surprising amount of fish as well. And why is that? Well, they're having trouble competing with the Brazils and Thailands and Chinas and so on. And that's an income issue as well as an environmental issue. And those countries need to sort of figure out how can they promote their own poultry and aquaculture sectors. I don't see an environmental problem there. I think that needs to be done. The question was about meat, but I would differentiate. I would add dairy to the mix too. Dairy is quite different, I think. I don't think a lot of tropical countries have huge potential for dairy. And I think there's some lessons to be learned from Southeast Asian countries, as I mentioned in my talk, where they're producing dairy in the few geographical areas like the Vietnamese highlands, et cetera, where they have a bit of potential. But otherwise, they're relying on imports from producers that are more efficient and, as Frank said, probably producing a lot more milk per unit of methane. And that could be probably good from an environmental perspective. And hopefully there's a balance there to meet nutritional needs. And what I think is, high potential for dairy to improve nutrition in a sort of mixed a model or strategy that is pretty heavily import dependent.
Thank you. Thanks to both of you, Martin and Derek, on that response. I just want to go to Frank. You flagged a critical issue there on methane. We deal with methane, we improve cooling, and we can address the climate change challenge that we're facing. On the other hand, Jessica talks about inequity, whereby there are some places, and Derek's touched on that, where we need more animal source foods just to address the stunting, the malnutrition, and yet it's not affordable. Now, when we are dealing with this methane puzzle and in places where livestock could be the only source readily accessible for animal source food, which is the best production system that will take us to reducing that methane and helping us address the affordability and food accessibility issues? Over to you, Frank.
Yeah, so very important question. And so the last thing that you will hear from me is that we need to export what we do, let's say, in the United States to the rest of the world. That would be not the way forward. But to assist those countries that have very low efficiencies and a relatively high emission status per unit of food produced can be helped by, for example, establishing a veterinary sector. In many developing countries, veterinary care is not existent. Ectoparasites are rampant. Animals don't really digest a little bit of nutrients that they are offered in a productive way because parasites are in the way, diseases are in the way, the feed is insufficient and so on. So in my opinion, what we really need is a new green revolution, one where countries throughout the world that don't have the means to produce a efficient and relatively environmentally sustainable product, that they are unable to do so. And here there has to be way more developing aid. And that includes countries like India, many African countries. Just think about this. In the United States, we have 9 million dairy cows. In India, there are 300 million dairy cows and buffalo. They could produce the same amount of product with a fraction of what they currently use. And I think we can learn a lot from each other, and we have to assist each other in getting this done.
Yep. Thank you very much. Already there is a complaint on the chat about India being the largest exporter of rice, groundwater depletion issues associated with that process leading to a water crisis. So yeah, we need a balance, we need technology, but also we need policies that are adaptive and respond to solving these problems. There is a question from Ambali. When recommending alternative proteins, it suggests attention should be shifted to plant-based proteins. Does this mean reduction in animal production for sustainable development? How can we balance reduction in greenhouse gases with sustainable livestock production and economic development? Over to you both, Jess and Frank.
Maybe I'll say one thing, and it'd be good to hear Frank's view on this. I mean, these industries, whether it's plant-based proteins or fermentation or cell culture technologies, and they're a huge growth industry, right? It's at 20, 25 billion a year, and their growth is somewhere between 7 to 10% out to 2025. When you read about some of these tech companies that are developing these technologies, they want to be incredibly disruptive. You'll hear comments of eliminating livestock from the planet. Whether that's based in any kind of realism is another conversation to have. But they want to be disruptive. And so that means reducing the number of animals that roam the planet and moving towards these other sources. Now, are they all cut from the same cloth, all of these companies? No, but many of them are aiming to be quite disruptive in what they do. I'd be curious to hear Frank's view on that.
Well,
you, Frank?
Yeah, so first, I think that it's good that there are alternatives, okay? And if people choose to eat this, then they should be able to. There's no question. We do have a drastic increase in protein needs throughout the world, and if these companies can help supply that demand, then that's even better. What I'm skeptical of are such statements as we need to divorce ourselves from animal sourced foods and get rid of it by the year 2035. That's one of the statements we hear from one of these companies. That is just so divorced from reality that it doesn't really help us addressing those critical topics that we are after. The critical topics really are, do livestock producers have a significant environmental impact? The answer is yes. So the question then becomes, how can we reduce that? Well, first we need to quantify it accurately. And then secondly, we need to find ways to minimize those impacts to the largest extent we know of. Do we need to eat less animal source foods in part of the world? Yes. In other parts of the world, as Derek and others have said, that is not the solution because we are not eating enough. So these topics are very, very nuanced and difficult. And some of those taglines that I hear from some of the companies that offer some of the plant-based alternatives are not going deep enough. Plus, personally, I and my family, we will not eat those things because we are very skeptical of the ultra-processed nature of it, and we just don't think that these are wholesome foods that we want to put into our bodies. But that's everybody's choices.
Thank you. Quick one from Derek. Your hand is up.
Yeah, so I think another thing, it's watching the chats there as well. So when we talk about the health impacts of animal source foods, this stuff is very nuanced. I mean, the Eat Lancet report, I think, was fairly substantially written from the point of view of sort of Western consumers. A lot of us in our 40s and 50s, yes, we're eating too much red meat, and there's evidence around that. Look at the demographic profiles of developing countries. So Frank mentioned a great statistic on how many cows there are in India. How many children are there in India under the age of 5 or under the age of 15? I mean, I had to find this fact out last year. There are 110 million children under the age of 5 in India. That's over 5 times the population of Australia, the total population of Australia, right? In Africa, I don't have that statistic, but it's also going to be enormous. So I think those young children who are undernourished, this is another global challenge, not just, this is a climate change challenge, of course, but there's a massive challenge of undernutrition and cognitive development that feeds into human capital and economic growth. And those countries are facing a huge challenge on that front, not just climate change. So that goes back to the inequity issues that Jessica raised. We need to find solutions for that problem as well, not just for the environmental problem.
Thank you so much, Derek. And I think you're partly answering the question in light of everything that is known about the link between animal agriculture and climate change, and the fact that people in the global south will be affected by its consequences more severely. Is it ethical or even useful to be discussing the consumption of animal products? Shame on you. Instead of discussing on more sustainable solutions for global hunger, especially with the increasing evidence on how a plant-rich diet benefits health as well. Jess, you said it. Give us one sentence on equity and affordability. Derek, give us the nutrient density and bioavailability of the animal source foods that you talked about. And over to you, Martin, in terms of the overview of where do we go from here, and Frank on methane. We have 1 minute for all of you to close in on those key issues, basing on this big controversy of why are you wasting our time, you panelists, talking about the future of meat and livestock. Over to you. Last round, please. Quick. 5 seconds each.
So from my perspective, there just needs to be a shift in the equity of who gets access to what. High income countries that are significant meat consumers need to make much bigger changes than, say, the household in Bangladesh.
Thank you. Thank you.
It just needs to be a reshifting now.
Eric?
Yeah, I mean, I just totally agree with Jessica, and I think that's a huge research question. So let's, since we're mostly researchers here, let's think about how to address those research questions. What's going to be the potential trends in the West, and how can we catalyze more of the right kind of health food consumption in poor countries?
Frank?
Yeah, well, methane is often described as a super pollutant. I think methane is also a super opportunity, because if
Thank you on that opportunity statement. Finally, Martin, 5 seconds.
Well, I think we need the discussion about the topic, because the topic is reality and will remain reality. Even if we would wish all people to be vegetarians, it's not going to happen anytime soon. And therefore,
on that note, we will have livestock with us until the end of time. So let's continue researching, let's continue debating. We have to talk about the future of meat and livestock. Thank you, panelists. Thank you to our audience. It's been an awesome session. We meet again. Thank you very much.